Our aim today is 10.2, conditional probability. Your homework tonight is Delta Math, scrap paper required. So set definition. A set is simply a collection of things, numbers, objects, etc., that satisfy a well-defined criteria. The things that are contained in the set are called elements of the set. A set and its complement, elements not in the set, are important when we look at the probability because all outcomes fall into an element or fall into an event or its complement, but not both. The union and intersection of two sets. The union is A or B. So you can be a part of it. You can be a part of the set if you fall into at least one of the criteria. Now notice that the probability of A or B, we take the probability of A plus the probability of B. However, we subtract the probability of A and B because those things have already been counted either with A or with B. So to include it again will be considered double dipping. And we take the intersection of A and B. So for the intersection of A and B, it must satisfy both criteria. So here's an example. In drawing a card from a deck of cards, there is a major difference in the way in which the following is calculated. So the probability of drawing a heart or a club. Notice the probability of drawing a heart based on the information here is 13 out of 22 plus 3 out of 22. However, we subtract the probability of a heart and a club. Notice that no card satisfies both. And our total sum would be 16 out of 22. Now, the probability of drawing a heart or a face card. Well, the probability of drawing a heart is 13 out of 22, and the probability of drawing a face card is 12 out of 22. However, we subtract the intersection of the two because you do have some cards that are hearts and face cards, and so they've been counted already. So we deduct those three, and we get 22 out of 22, which covers all of the cards that are listed here in the diagram. So a two-way frequency shows how events or sets can combine the union or the overlapping intersection. So it's a way of looking at two different sets of data together. So let's look at the following values. Now the number of out of the 52, those that are male, 30, female, 22, going to college, 29, not going to college, 23, male and going to college. Notice it's an and statement, so you add the probability or the elements that are male plus the elements that go to college, and you would get 16. Female and going to college, it's also the intersection, so that would be 13. Now, female or college, you have to calculate the probability of being female, 22, going to college, 29, but then we also have to deduct the 13 that count in the intersection of those, and we get 38. So conditional probability. When the probability of one event occurring changes depending on other events occurring, then we say that this is conditional probability. You can write a conditional probability using the following notation. This is read as the probability of event B given event A. For any two events, A and B, from a sample space, the probability of A cannot be equal to 0 because having a denominator of 0 is undefined. So let's look back at our two-way frequency table again. So now let's calculate the probability of the following. Going to college, given that they are female. So we have to calculate the probability of female and going to college, which would be 13. out of the total number of females, which is 22. Which is more likely, that a person picked at random will be going to college given that they are male, or that a person will be male given that they are going to college? Well, let's calculate them. So college and male would be 16 out of total males, 30, which is approximately 0.53. Now, the probability of being a male and going to college is 16. However, we compare that with those overall that go to college, which is 29. And that's approximately 0.55. So the conclusion, it is slightly less likely that a person picked at random will be going to college given that they are male than being a male given that they are going to college. Joint relative frequencies. The values in each category are divided by the total number of values in a two-way table. Marginal relative frequencies. The sum of all the joint frequencies in each row and column of a two-way table. So essentially, we're computing the percentage for the overall. So it'll be represented as a decimal, and in the bottom right-hand corner, all sums will add up to 1. So here, find the probability that a person picked has brown eyes given that they have blonde hair. So we look at the probability of brown and blonde. So here, that would be 0.1 or 10%. And the probability of being blonde is 35%, and therefore the overall probability would be approximately 29%, because 0.1 divided by 0.35 is approximately 2.9. Now, the probability that the person has red hair, given that they have green eyes. So let's look at the person has red hair, given that they have green eyes. That's 0.15. And let's compare that to the overall population that has green eyes. And that's 0.25. And so that's approximately 60%. So now, does having red hair seem to have more dependence on having green eyes? Well, we can determine this by looking at the overall probability of having red hair to the probability of having red hair given that you have green eyes. So the overall probability of having red hair is just 20%. However, having red hair given green eyes, that was 0.60 or 0.6 or 60%. So a person is 3 times more likely to have red hair if they have green eyes than if they were just to be picked from the overall population. And your homework tonight is Delta Math. Scrap paper is required.